We're going to go over the answers for our 2-2 exit slip. Our goal for this lesson was to be able to find the least common multiple for numbers and use that to help us solve some real world problems. So we'll take a look at a couple different problems here. To find the least common multiple, you have some different options. One option is you could just the skip counting, where you just list the multiples. So I could list, and this works well with smaller numbers, okay, and we just list a few multiples. 4, 8, 12, 16, multiples go forever, so we can just list a few and try and find the least common one between these numbers. Now if I start listing these for 6, I've got 6 and 12, and I can see right away when I do it this way, my least common multiple is 12. And you don't have to list multiples very far sometimes in small numbers to be able to find these. Remember, we can also use the grid method, which I know we learned this to deal with factors, but it also helps us with multiples if we need it to. So if I can list 4 and 6 up here in the top of my grid, remember, even though I'm finding multiples here, the grid method, we pull out common factors. Okay, what can both of these divide by? So if I have a 4 and a 6, they're both even, so I know they divide by 2. So 4 divided by 2 is 2, and 6 divided by 2 is 3. And we know 2 and 3 are relatively prime. There's no other common factors but 1. So then this is where as low as I can go in this grid method. Now, to find, I know the greatest common factor is 2, but my job is to find the least common multiple. And this works every time. You can simply make an L through here. I use that to remind me the L for the least common multiple. And we need to multiply all of these together. So 2 times 2 is 4, and 4 times 3 is 12. And this works every single time. Very, very efficient if you can use that grid method to get it broken down. Okay. 5 and 7, another way sometimes is you can just, the least common multiple is just multiplying the 5 and 7 together. And you don't always know if that will work with that strategy, but let's do a quick grid method just to double check. And sometimes this can look a little weird, but if I have a 5 and a 7, the only thing they have in common, the only factor in common is a 1. So if I pull out a 1, 5 divided by 1 is still 5, and 7 divided by 1 is still 7. So really, it didn't change it at all, but I can make that L through here and multiply them. 1 times 5 is 5, and 5 times 7 is 35, and we get that least common multiple of 35 in this case. And you can always take these two numbers that they give us and multiply them and you'll get a common factor. It just won't always be the least one. For example, in the first one, 4 times 6 is 24. That's a common multiple. Excuse me, I think I said factor earlier, but that's a common multiple, but it's not the least common one. And we usually like to get that least common one. Keeps our terms a little bit smaller. So in that case, the numbers are a little bit easier to work with when we start doing some other things with them. So this is our first example of how to use that grid method to find the least common multiple, or the skip counting method. Either of those work well. Okay, so make sure you get these written down here. We'll pause the video if we need to, or if you're watching at home, you need to pause it and get these written down. Please do. And then we're going to go ahead and take a look at another example here. All right, so real life type problem now, where you can see something like this. Okay, let's look at the second one that was on your exit slip. It talks about the Awesome Bowl Factory. Makes 2 kinds of bowls. They produce a basic bowl every 6 minutes and a gigantic bowl every 8 minutes. And they start at 7 o'clock in the morning. So we need to figure out what time are the basic bowl and the gigantic bowl first produced together. Well, it's the first time that they're made at the exact same time. And that's a very common least common multiple type problem. All right, because I need to find the multiples, the least common multiple of 6 and 8. So I could do some skip counting by time, or I could do a grid method with multiples. So I'll go ahead and show a grid method here. And I've got every 6 minutes and every 8 minutes. So I want to find the least common multiple of 6 and 8. So I know to do this grid method, I'm going to pull out a common factor. I know they're both even, so they divide by 2. 6 divided by 2 is 3. And 8 divided by 2 is 4. So now the 3 and 4 are relatively prime. So to find that least common multiple, I can multiply all of these together. 2 times 3 is 6, and then 6 times 4 is 24. So in other words, it's going to take 24 minutes for them to be made at the exact same time. So if I start at 7 and I go 24 minutes, first time they're produced together would be 7:24 a.m. there in the morning. It only takes 24 minutes, and at 7:24, both of those would get made, one of each at the exact same time. So again, the grid method works. I could have listed and started counting 7 o'clock, 7:06, 7:12. I could have gone by multiples of 6 and then done it again by multiples of 8, 7:08, 7:16. And you would see at 7:24, they would have both landed on there. So either one of those method works, the skip counting or the grid method. And there's our answer for the second exit slip question.